Algebra I 10.8b, Rational Equation Word Problem, Mixture of Solutions. So I want you to remember that solution can be the answer to a problem. We can find the solution to a problem, but a solution can also be a mixture of liquids, okay? So there's two meanings, all right? So word problems that contain mixtures can be solved easier if we make a table to organize our information. The table will help us write our equations. So here we have a table, and if you look at how I set it up, this is a mixture of solutions word problem. I've got the first solution here, the second mixture solution here, and the final solution of these two added together that is going to be this last one here. Here is the amount of the solution. This would be 1 liter. This is the amount of solution that has a percentage of salt, and this is the amount written as a decimal times that 1 liter, see? All right, and I'll explain this a little more as we go on, all right? So this is what we've got. We've got a 20% salt water solution, and there's a liter of it. Then we've got water that's got no salt in it. It's clean, all right, but we don't know how much there is. Then we've got a 6% salt water solution, and when we mix these two together, when we add these together, we want to get that one, okay? So here's our problem. From 1963 to 1984, the water level in the Great Salt Lake in Utah rose. It went up. The lake expanded from 900 square miles to 2,300 square miles. And during this time, the salinity of the lake, that's how salty it was, dropped from 20% to 6%. The reason the saltiness dropped is because more clean water was added to it, and it made that salt water weaker, didn't it? So how much water would have to be added to 1 liter of lake water that is 20% salt to get a solution that's only 6% salt? Okay? So we're going to let X be the amount of water that was added to the solution. Okay? This is the amount of clean water. We're going to let 1 plus X be the amount of the new solution. And we're going to let 0.2 for 20% times 1 equal the percentage of salt as a decimal right here multiplied by the amount of the solution. See? So this is 1 liter times 20%, and this is written as a decimal as 0.2, all right? Because that's how you write 20%. We're going to let 0 equal the percentage of salt in the water that is added to make this new solution. So this is the clean water, okay? And then this down here, we're going to let 0.06 times 1 plus X be the percentage of salt as a decimal multiplied by the amount of the solution. So the way we write 6% as a decimal is 0.06, and we're going to multiply it by this 1 liter plus this X, see? So you can see we got 1 plus X coming down here. We've got 20%, and we've got 0% for the clean water, and it's going to be 6%. And then here's our equation. 0.2 times 1 plus 0 is going to equal 0.06 times 1 plus X. See? That's going to be our first equation. See? All right. So here's our equation. 0.2 times 1 plus 0 equals 0.06 times 1 plus X. We're going to multiply the 0.2 times 1, and that gives us a 2. Adding the 0, we can just forget about that, can't we? Because it's going to just be the 2, isn't it? That's going to equal, when we multiply this 0.06 times 1, we get 0.6. And when we multiply 0.06 times X, we get 0.6X. See? By multiplying it by the 1, it moves the decimal point over 1 space. We've still got decimals in the equation. We can multiply every term by 10 to get rid of that decimal, couldn't we? That'll move it to the back of the 6 and to the back of this 6, but it'll make that a 20. So now our new equation says 20 is equal to 6 plus 6x. To get rid of this 6 here, because we want to isolate the x to solve it, don't we? We subtract 6 from here and subtract 6 from here. That creates a 0 pair, and it's eliminated. And 20 take away 6 is 14. We drop our 6x, and we have 14 is equal to 6x. Now we just divide each side by this coefficient 6, don't we? Then we get our friend the invisible 1 identity property, and we get 14 over 6. When we simplify 14 over 6, we get 2 1/3. So 2 1/3 is approximately what x is equal to, or 2.33. And the 3 would continue, right? Because it's a third. That's how many liters x would be. See? So that's how many liters of clean, unsalty water we would need to add to a liter of 20% water to get the 6% one. See? We would need to add approximately 2 1/3 liters of unsalted water for every existing liter of 20% salt water that's in the lake to get a 6% salinity saltiness in the lake. That's how the saltiness got lowered. Remember, because 0.33 equals a third, and it's a non-terminating decimal, we use that approximate symbol. Because it's not exact, is it? Because this 333 keeps going on, right? Remember that 1 is equal to 100%. Our next video, 10.8c, we're going to talk about rational equations and a mixture of money for a word problem. If you want to see any of the previous videos, we did the reciprocal of a number word problem, or adding and subtracting unlike denominators with a pattern. There's a link to my algebra word problem playlist that has lots of word problems like this in it. We did one with distance, rate, and time, or the previous one for acid mixture. All those links are going to be in here to help you out, okay? There you go. All right, so let's talk about a mixture of money, and I hope this was helpful, and I'll see you there. Bye.